Welcome, everyone. I'm very excited to see the room almost full here. I'm glad you came for this talk about Google Web Toolkit, or how we like to refer to it as GWT. And today we want to talk about GWT app architecture best practices. How to architect your application in Google Web Toolkit. And this talk is actually based on the talk given by Ray Ryan at Google I/O recently, and he was gracious enough to let me borrow his slides for you today. So what are we going to talk about? We're going to talk about how to organize a non-trivial GWT application, so something more than Hello World, a complex application with a lot of things going on. And we're going to focus on the client side. This is interesting to me, and this is where GWT does its work. And we're going to do that in the context of the AdWords UI. AdWords is an interface that we use to allow you to manage your ads with Google. So let me show you just a few screenshots of this application to give you an idea that it's more than just Hello World. And at the bottom is a URL, and you can investigate and look at this more for yourself. If you, for some reason, want to leave and see a different talk because this one's not applicable, I have a few things for you to take away. If you remember nothing else, make sure that when you develop your application, you get browser history right, and do it early in the development cycle. Also, use an event bus to get rid of spaghetti or complexity. When various widgets in your application are all tied together and it's becoming difficult, think about the event bus. And this little acronym here, DI plus MVP FTW. What does that mean? It's a nice way of saying dependency injection, which is a pattern, and model view presenter, which is another pattern, for the win. And I want to talk about all of these things throughout the presentation, but this is just the high-level takeaways for you today. We'll have three major themes throughout this. We're going to, in designing our application, embrace asynchrony, which means think about everything as if it were asynchronous. Always be decoupling. Always try to make the left side of your application know less about the right side of your application, if at all possible. And strive to achieve statelessness. Try to make sure that your application deals well with restarts and refreshes. So first thing, embrace asynchrony. Well, remember we're talking about AJAX applications in the browser, because this is Google Web Toolkit. And what does the A stand for? A is for asynchronous. So let's start with a simple model class. And I'll have a lot of code samples here, and I'll try to walk through most of them. This class represents a contact in an address book. So I might be a contact, my wife, my friends, they're contacts. And each of these contacts has a number of details, like a phone number, maybe multiple phone numbers, an email address, an IM handle. So those are contact details. So in this case, the contact, the name might be Fred, details might be my cell phone, my home number, and my work email, my home email. And you see it's quite simple to set up a model class. But there's one problem here, which is we've supplied all the details of my contact here within the model object. Now, if I have a user interface that needs to pull in hundreds of contacts, that's a lot of additional information to pull down, which the user might never see. So we don't want to do this. What do we want to do? Well, we want to instead use one level of indirection. We want to pull the contact details asynchronously. So instead of a list of contact details, we just supply a list of contact detail IDs. And then when we need to, we can fetch those details. So in the address book, when someone clicks on my friend, then we can go to the server and retrieve those details. A good way to do the asynchronous work in the application and make life easier as a developer is to use the command pattern. And it's a good way, it allows us to, the command pattern allows you to leverage for caching and batching of multiple gets or puts to the server. So if I have to retrieve 3 different things from the server, maybe I can wrap them in a single RPC call to the server, a single HTTP round trip, which makes my application more efficient. I can also centralize failure handling by implementing the command pattern. So when the address book fails to update or a different part of my UI, I can handle those errors all in one place. The command pattern also lays the groundwork for code splitting. This is something that GWT does called run async. It allows you to split your application in 2 parts, or 3 parts, or 4 parts, so that when a user comes to your website, they only get the essential code that they need for the first part of the application. And then as they dive into the application, we can download additional pieces of JavaScript. This makes the experience much faster, especially on mobile devices. Command patterns are also great for implementing undo and redo, because you've already wrapped every single user action in a small command that you can play backwards if you like. And it's good for starting to work with gears or HTML5. So let's use the command pattern. What does that look like? Well, the term command is actually taken in GWT, so we're going to use action instead. We define an interface, an action interface, and we have parameterized it with a type T. And T simply extends response. The response interface is not that interesting. We just have it in there so the code reads a little bit better right now. Then we need to define a couple of GWT RPC methods. Now, if you've written any GWT RPC, these look very familiar to you. First, you define a service class, and you extend remote service. This is all very standard. You define a method. In this case, we've chosen to define an execute method, and it takes a command or an action parameterized by T, and T extends response. Now in GWT, every time you write the service interface definition here, you also need to write an asynchronous version. This is the exact same method, but the return type is now changed to void, and instead we have the second parameter, the asynchronous callback. And again, this looks very familiar if you've done GWT RPC. So what does an action look like? Well, let's say we need to get those details from the server. I need to get all the phone numbers for my contact. Well, I define a class, get details, and I implement the action interface, and it's just parameterized by the type get details response. So I need to store a list of IDs that I want to get the contacts for, or the contact details for. I also need a getter, I create a constructor which will capture the IDs that I have and put them in this private field. Then I have a getter to get those IDs. And I'm done. This is my action class. Very straightforward. Now the response. Get details response implements the response interface, of course. We have a list of details that we need to return from the server to the client. And we have a constructor that takes a list of contacts. We set our field. And of course we need a getter to return results, but we make a defensive copy so that the client can make any changes to the details without affecting the original copy. Now, let's add a third class, a convenience callback. We're going to need a lot of asynchronous callbacks, so let's actually create a little wrapper class for that. It's a class called GotDetails, extends or implements asynchronous callback, and we have an onFailure method. But rather than deal with that specific error right here, we're just going to call an application-wide error message so that we can display that to the user. Usually what's happened is the communication to the server has been lost, and so there's no reasonable way that we can recover locally. We need the application to maybe refresh itself or try again. The onSuccess method, however, we're going to delegate to this new method called got. And that's just a method that we've chosen here. And we're going to pass in the details that we got from the result. And here's that new method. We defined it as abstract. so that all subclasses are going to be required to be implemented. So what you see here is very interesting. We have this abstract class called got details. And when we create an anonymous instance of that, we only have to implement the got method. So it's going to be very easy. We don't need the on failure or on success. So let's do that. When our application needs to show a contact, we call it show contact method. So we're going to call the RPC service, and we're going to execute an action. Well, that was the get details class. And we also need an asynchronous callback, which we just created in the previous slide. So we create one of those, and we implement that got method. And all we do is render the context. So now, when a user in the user interface clicks on a contact to be shown, we call the service and issue an asynchronous request to get the contact details. And when that succeeds, our method got is called, and the contacts are rendered. So if everything's moving smoothly, the user clicks, and almost immediately the data comes back from the server and the contact's displayed. If there's some sort of error, we can handle that. But we've made everything nice and asynchronous. So what is our second theme? Our second theme was always be decoupling. Always be the left side of your application, no less about the right side of your application. Well, why do you do this? Well, if you have the combination, we say, if the combination of the event bus and dependency injection for any global services like the RPC service or the event bus, and the MVP pattern for your custom widgets, you get some benefits. For example, you can easily rejigger your application, meaning you can make changes, design changes, move things around, and you don't have to change a lot of integration between the different services. You easily can defer or make asynchronous parts of your application that might be tricky, DOM manipulations. And you get very easy unit testing, fast unit testing. This is important. So, the theme of always decoupling. First, let's look at the event bus. We're going to do that in the context of an existing application and MVC model that you might be familiar with. This is how we often build user interfaces. We start with some model objects in the middle. We have contacts. These represent contacts in my address book. And we have groups. Groups of various contacts together, like all my family members. And each of those has to be tied into the RPC service so that they can get their information from the server and update themselves. Then any UI elements, these are widgets on the screen, need to listen for property change events. So the groups UI listens to each of the groups for changes. The contact list UI needs to listen to changes for each of the contacts. These are property change events. Now, when you click on an individual contact, you need to display that. And we need to wire any changes in. Remember, every time a model object changes, we have to notify all the widgets that are listening for it, all the places on the screen that might be impacted. And this is where we're starting to create spaghetti. Everything is connected to something else in multiple ways. If we want a window title at the top or a breadcrumb to show our navigation path through the UI, everything is wired into everything else. It's really hard to move pieces around. It's really hard to get this right. So let's try to loosen this up a bit. Let's use that event bus idea. Let's make all the UI widgets, which are now wired together, talk to each other via the event bus to get rid of some of the spaghetti. This looks a little bit better. But we can take it a step further. We can get rid of the model objects as the canonical copy of the data. Here, the model objects are the center of the universe. There's only one copy of the contact thread, and every time it changes, everyone's notified. Here, the model objects live on the wire. They're not drawn here because they just get passed around. Copies of them get passed around. When the RPC service returns a new copy, a new instance of the thread, it just gets sent to the widgets. When the widgets update the contact thread, they can send a copy of that model object to the event bus. So these model objects are no longer the center of the universe. They're just disposable objects. Here's the method that we looked at earlier, the show contact method. We're going to change it a little bit. We're going to add an if statement. What we're doing here is just to say, only show a contact if the contact that needs to be shown is different from the one we've already shown. This makes it so that we don't do unnecessary updates. The other thing we want to do is we want to listen for updates to the contact we actually are displaying currently. What we do is we ask the event bus to register another handler. And we want to do that for the contact change type event. So we create a new anonymous interclass contact change event handler, and it has a method on contact change. Every time we get an event, we get the contact from it, and we compare it to the current contact ID that we have. And if they are the same, this contact that we are currently displaying has in fact changed, well then we need to render the new contact because something is different. And what you notice here is that instead of listening for property change events on the original contact, we're actually just listening for any copy of the model object coming in that has the same contact ID. And we say, well, the new copy that came in must be the new good version, and we'll just start using that. Now, we also want to toss the event on the event bus. In the client, there are many UI widgets that are interested in these updates. Well, an easy way to do that is instead of making calls to the actual service interface, the RPC service, we can make a call to a kind of a fake service or an in-between service. And it's that method here that we're looking at. So someone calls the execute method here, and they want to update a contact, so they pass in a new update contact action. And we create an asynchronous callback. And the first thing we do is we call the real RPC service, because we need to tell the server that we've made a change. But we also create our own asynchronous callback. And what do we do there? Well, in the onFailure method, we just delegate to the original callback handler. We're not too concerned about that. But on success, we want to do a few special things. First, we call recache, so that we update our local cache with the latest copy of the contact. And then we call on success of the original callback handler. That takes care of the responsibility of dealing with the original callback. But then we want to toss the event on the bus, and those are the last two methods of this class, where we say, create a new contact change event, and then event bus.fire event. So now that contact change event sits on the bus, and anyone who's interested in that update will now see that. We're still trying to decouple, and we looked at the event bus. Now let's look at MVP. Well, what is MVP? First, we should maybe understand MVC, which you've probably heard about. This is the classic model view controller pattern that you've maybe seen many times. What's interesting is that if you ask two different people, you probably get two different answers of what this really means. It's really hard to define where your code lives. If you have a particular piece of business logic or UI logic, where does it belong? Does it go in the controller? Does it go in the view? Is it something that should be in the model? The other thing that's very hard here is that when I want to do any kind of testing, I need to have all three components because they're all wired together. I can't test them in isolation. So it's really hard to create mock objects. And also, the view, in this case, is the web browser. It's slow in testing terms. If I want to run 10,000 unit tests, and for each unit test I have to spin up a new browser process on my machine, that's going to take a long time. So, to the rescue is Model View Presenter, a new pattern that changes the way we look at things a little bit. Here, the model is very simple. It's the model class we looked at before the contact. The view, again, is very simple. It's just widgets, dealing with DOM operations and event handling within the browser. All of my valuable logic, the thing that makes my UI what it is, goes in the presenter. And that's a pure Java class that I can test independently. So while the view, very slow, it's still a browser, what we can do is use quit mark utilities and actually use mock view. We can, instead of a real widget, we can take a fake widget. And because it's so simple, we don't have any application-specific logic in the widget that we're worried about. So we, in fact, can make the view very fast. And then we can run thousands of unit tests in a very short amount of time. So model, view, presenter. What does the model look like? Well, this is the class you saw at the earlier slide. Very simple POJO, plain old Java object, where you have a few properties, you have getter and setter methods. There's no event handling. This is the simplest object you could write. The presenter is something we'll dive into a little bit more detail, but this is where all my custom logic is. But notice that there's a display interface. Think of that as the view interface. This is an interface that we declare here that will help us later on. And the view is just a simple set of widgets. But this view will actually implement that interface. So now let's look at the presenter, that middle piece, that very important piece where all our logic lives. We call it a phone editor, but think of it as a phone presenter. So it displays a piece of contact detail information and the logic for that. I said that we had a view interface, that's declared here. Our view has a save button, a cancel button, a phone number field, and a label field. Not very complicated. But notice that we don't declare the save button as being a button. Instead, we say this is a has click handlers. And we use that interface to keep ourselves straight and to keep it simple. It's much easier to mock a has click handlers interface than it is to mock the entire button. If we only need to know about the click functionality, this helps us out. So how do we bind to the display? Well, in the presenter, we'll have a method called bindDisplay that we call, and we pass in an instance of the display. And it's very simple. We say display.getSaveButton, which is that click handler. It could be a real button, it could be a mock button, depending if we're running in a real browser or in a fast unit test. And we simply add a click handler. And on click, we call doSave. Same thing for the cancel button. We get the cancel button, and we add a click handler called doCancel. Now, if we want to edit a phone, so someone clicks in the UI somewhere and says, I want to edit this phone number. Well, what do? Well, first line of code we call phone.from. And this is a static method that simply makes a defensive copy of the content. That way, if we make any local changes and the user hits cancel or undo, we can throw that object away and nothing's changed. We haven't affected any other global object. So we make a defensive copy, and then we take the phone number value and the label value, and we put those in the display, in the view. That's simple, and now the user can start editing or interacting with the view. So the doSave method that we associate in that click handler, what would that look like? Well, the user's done typing, they finished in the display, and they hit save. Well, we want to copy first the two values out of the widget, out of the display, and put them into a phone object. And then we want to call the RPC service, and we simply use our convenience action and response and asynchronous callback methods, or classes. So here we create a new update phone, that's an action, and we pass in the new phone object that we want to update. And we have a new asynchronous callback called updated phone. And it has an updated method, in which case we tear down the UI. We're done with the UI. The users edit their number, so we can remove it from the screen or turn off the editing. And then we've added this had errors method. That's probably called from on failure, and we can handle errors locally if we want. So we're still decoupling. We did MVP and the event bus. Now dependency injection. What is it and what can we do with it? Well, dependency injection, you've probably heard of it, and it sounds complicated, and you might want to use it, but you're not sure. But really, it's just a pattern. It's a pattern that you can implement by hand. It simply means there's no globals. There's no single global class that everyone has access to where you say global.getService, global.getEventBus. We don't want that. There's no service locator. So there's no single place where we can go get the RPC service. Instead, all our dependencies are pushed in, preferably via the constructor. That means if my particular phone editor needs an event bus, then we just have an argument in the constructor, and it gets passed in. It's not hard to do manually. In fact, for the AdWords UI, I think currently they actually do it manually because the code there predates Gin and Juice. Gin and Juice are a couple of projects that make it easier to do dependency injection. Gin does it on the client side in GWT code, and Juice does it on the server side. But you're certainly free to do it by hand, experiment first, and then later use these tools. So this is what it looks like by hand. This is a long method, but it's really simple stuff. And actually, it makes sense if you start reading the code from the bottom. The very last line is the one we care about. The one at the bottom that says contactviewer.go, rootpanel.get. That simply says, take my contact viewer, my widget, and attach itself to the panel. Well, what do I need? I need a contact viewer, so how do I create those? So the line right above that, we construct a new contact viewer. But the constructor has 4 parameters. It needs a contact widget, a phone editor, an RPC service, and an event bus. Those 4 things need to be created. So if you look at the lines right above it, we create a contact widget, and we create a phone editor. Oh, but wait, the phone editor has 2 requirements. It needs a phone edit widget and an RPC service. So we create those in the lines above that. And walking the code backwards, you can see that we create each of the dependencies until we reach the top, and we've satisfied all the dependencies. So that's what the code looks like written by hand. It looks like a lot, but it's very easy. Everything's just a constructor passing in our dependencies. If now we want to add another dependency, let's say we want to use the Google Voice service for the phone editor. Well, we add that parameter, looking at the bottom half of the chain, and that turns out we need a new voice service. So we just instantiate one of those. So that these 2 changes are the only ones we need to make. Now, in your application, or at least ones that I've written, this is a lot more complicated. Usually, you call a constructor and you pass in some things, and then when it creates an object, you pass in some more things. And you end up with this chain where, in order to go all the way down here and pass in the Google Voice service, you need to pass it in there, and then you need to pass it in there, and then there's this method. And you end up changing 5, 6, 7, 8, 9, 10 different places to pass in that dependency. But what dependency injection does is it says, no, you just pass it in once, like this. Now I also want to show you this method. This is the exact same method as this one right here. Now this is the hand-coded version where I've done all my object creation manually. When I use Gin dependency injection, I have 2 lines of code. The second one is the one I wanted. It's the create contactviewer.go. And right before that, I have to create my Gin injector. That's it. That's the power of dependency injection. So why do we do decoupling? Well, one of the payoffs is that our tests run fast, which I've talked about. So let's set that up. Let's create a mock contact service. So this is a fake RPC service. It's not the real thing. It's something I want to use in testing. If I were to do a test with a real RPC service, that has 2 problems. One is that I have to communicate round trip with the server, and that's slow. It's slow in the order of testing. It also means that I have dependencies on the server. So if there's a problem on the server or a new version of code on the server, I might find bad test results locally. I don't want that. I want to test my local phone editor. So I create this mock service, a fake service. It implements the contact service async. And I have 2 fields here, the last action and the last callback. And these are just fields that I use to store information. I have the execute method that we've defined before, And the only thing I do in this execute method is I save the action into the last action field and save the callback into the last callback field. So I can test for those. I'm going to create a mock click event. It's a fake click event. And I create a class called mock has click handlers. It implements the has click handlers interface. So this is where, instead of implementing the button and having to mock all the button functionality, we're only mocking the click handler functionality, which saves us a lot of work. So here we want to store the last click handler. And the very bottom, we have a fire event method. It doesn't do anything because we don't really use that within our application. We create a mock has value method. Remember the model had a phone number field and a label field. And both of those were defined not as text box and label, but they were both defined as has value. So we can mock both of those things out, even though they're different, with a single class here. We can mock out both the label and the text field. So very simple class, parameterized by type T, so we can have strings and integers, different values. And we store the last value that was set. One more mock class before we get the payoff. So you see, it may be a lot of work to create these mock classes by hand, but they're all very simple to do and they're reusable. You can also use GWT mock or mock utilities, or there's a whole set of tools out there that will create mocks for you, so that this slide and this slide and this slide and this slide that we all looked at can all be built fairly automatically. So this is the last of our mock classes, a mock display, so a mock view class. Here we have a fake save button called save, and it's a mock click handler, a fake cancel button, a fake label picker, and we just save those off. So now our test. This is the thing that we wanted to do. We wanted to be able to test our code in a unit test case without server interaction, with very fast mocks, without a web browser. Here we finally get to do it. We create a mock contact service, a mock phone editor, and then we generate a new ID. This is a contact detail ID. And we build the before and after values. These are the things we're going to test against. So we create a new phone, and it's a home phone. Put the phone number in, 1234566, and then we create a copy of that and modify it. Say, okay, this is now a work phone. And now we're going to test as if the user had made those changes. Create a phone editor. This is the presenter part of the application. This is the thing that we're testing. And when we call edit phone, and we give it the before phone value, and then we call on the mock display, we say label picker set value work, and phone number field set value 098-765-4321. Then we call our mock click handler, and we say on click, and we pass it a mock event. Now, if everything's working right, our test should succeed. So we verify it. We get the action from the mock service, the update phone action, and we assert that it equals a new action that we create. We get the actual phone number, and we compare it with the expected phone number. And if all these things return true, then our test succeeds. If we have any problems in the presenter, our test will fail. Our third theme today was striving to achieve statelessness. So disposable servers, disposable clients. First, disposable servers. When a server crashes, you don't want it to affect users. You want the users to pick up their session or their request on the very next server very quickly. And by using these client-side patterns, your state's in the client. And you can handle server restarts very quickly. The only state that should be in the server, really, is the persistent storage on the data store and maybe some caching. But it's only convenience caching. It's not something you rely upon. And users ultimately should not notice a server restart. If you have 100 machines and one of them just dies, all the users should be happy on the remaining 99 machines. And a good example is App Engine Memcache. It works like this. Disposable clients. What does that mean? Well, things happen in the browser. People reload their pages. Browsers can crash. And so we want to get good history right. And that means a couple of things. One, it means that users can use the back button and forward button to go to different states of your application. And what that means for your application depends on something you get to decide as a developer. But this also means bookmarkability. If you have different states in your application, for example, when I'm in my email and in my inbox and I open up one particular email and I hit the bookmark button, I want the browser to remember that that email was open. That's what that bookmark should mean, not that I had my webmail client open. So different states in my application, different emails. If I have a contact open, I should be able to bookmark that. And GWT history allows you to do that. One additional recommendation is that on top of the history mechanism within Google Web Toolkit, that you use another layer of abstraction, a place abstraction. And this is something that you can fire through the event bus. So when a user makes a state change in the application, like they go to a new contact, a new part of your app, you can fire an event off, a new place change event, send that on the bus, and then all the widgets that need to listen are interested in that can listen for that event on the bus. Disposable object models is another way of thinking about statelessness. In the old MVC model, we had model classes that were the center of everything. You could not dispose of them. There was a single contact that represented the state for that contact, and everyone listened for event changes on that contact. Don't do that. Don't fire property change events on model classes. Instead, create these disposable copies that you pass around like we showed in the examples. And that means that it's okay to throw these extra objects away. When I'm in the phone editor widget and someone has typed in the phone number, replaced it with a new number, and they decide that that's not a change they wanted and they hit cancel, you can throw that copy of the model object away and no one's hurt. A side effect of this is that we have multiple instances. My contact address in my user interface, there might be 5 copies of that floating around, or maybe 1. I don't know, but I really shouldn't care that much. It also means in your code that you expect multiple instances. You don't just update the model object and expect the rest of the UI to update. Everything goes via the event bus. So you might recall this diagram where we clean things up. We had one thing left to do, which was add the place abstraction. Well, let's do that. We add another service on the event bus, and it keeps track of our places in the UI, and different widgets can listen for place changes if they like. So I just want to recap what we talked about today. If you remembered nothing else, we said get history right, get it right early in the development cycle, start thinking about that from day one. Use the event bus to fight spaghetti. It makes it a lot easier to make changes to your application. And dependency injection plus model view presenter for the win. And then we had 3 major themes that should guide you in the process of building complex applications with GWT. Embrace asynchrony. Remember, Ajax, the A is for asynchronous. Everything that you do with the server needs to be asynchronous. If you block a call to the server, the UI will freeze, which we saw in the demo earlier today. You want to request the change, request the data, and let the UI run again. Let the user interact with the user interface while you get the data. And once you have a response or a failure, then you can update the UI. Always be decoupling. Always take the left side of your application and make it know less about the right side of your application. And then strive to achieve statelessness. Allow servers to be restarted. Allow browser clients to be refreshed. I want to leave you with this slide, which has a link to additional documentation for Google Web Toolkit and my contact information. You're free to send me an email, follow-up questions. And in fact, I think we have some time for questions right now. Thank you very much.
I have usually use MVP and UMDI, but I don't know, have you noticed the flags? In flags, there's something called debugging. If you do debugging, not only to the view to the presentation, you can do debugging to dynamically update the view and easily to test them. My question is, did GWT have a plan or solution to support debugging like a flag did?
So debugging support for Google Web Toolkit is actually, I think it's really good. One of the things that we do in Google Web Toolkit is give you as a developer the Java development environment, and also during development you get the Java runtime environment. So you can debug your application using the JVM, using an IDE. You can step through code in your application. You can set breakpoints. You can make changes to your code at runtime. You can inspect variables and change values. All the useful tools that you might be familiar with in Java environment, you get in Google Web Toolkit. And then when you deploy to production, there's the standard JavaScript tools that you can use, like Firebug. I think, were you asking specifically about dependency injection and testing?
Yes, because after you write a special code for testing, because you already injected the UI to the presentation layer. If you can do that, I think you need to run that code.
Well, so during your tests, you can have dependency injection automatically inject mock objects rather than real objects. So rather than a view, the dependency injection framework can interject a mock view. Rather than a regular model, can inject a mock model. And so dependency injection actually helps with that because it makes it easier to inject those different objects. And it forces you to write your application in such a way that the injection points are very easy. Everything happens in the constructors rather than a complex chain of dependencies. Does that help? Okay. Thank you.
Hello, Brad. I'm Frank from AISpeech.com. We're a company leader in intelligent speech software. I think in the browser we have some something called GWT voices. Could you give us a brief introduction to this?
Okay. Yeah. Before I joined Google, I created a few open source projects around Google Web Toolkit. And one of them is, in fact, GWT-Voices. The reason it has that name is that GWT-Sound was already taken. So I had to create a different project name. But the GWT Voices project tries to provide cross-browser sound support in Google Web Toolkit. So the mechanism by which you can play back sounds in Safari and IE and Firefox and Chrome is different for each browser. And the sound file types that are supported are different. And to deal with that complexity, I wrote GWT Voices, which allows you to play back sound If the user has a Flash plugin, it can use Flash for MP3 playback. In IE8, it can happen natively. Other browsers can play other formats like WAV files, MIDI files, etc. So that's a little bit about GWT voices. The other two projects are GWT DND for drag and drop and GWT-log. GWT log provides client-side logging. It also helps with mobile development. If you're testing a GWT application on a mobile browser, GWT log can send the log messages from the client to the server where you can see them in your IDE. And GDD drag and drop allows you to drag and drop single or multiple widgets in the browser. So move maybe contacts from one part of the application to another. Answer your question? Thank you. Yes. Right back.
Thank you. My question is, are you going to support the 64-bit platform product, GWT or Web Toolkit?
The short answer is yes, support for 64-bit is coming, but not in the form of a new 64-bit version of the current hosted mode, but we're actually moving to a new hosted mode model which uses the native browsers on each platform directly. So today, the current hosted mode, if you're familiar with that, on a Mac you always get a version of WebKit. And on Windows you always get a version of IE, and on Linux an old version of Mozilla. That is a restriction that's going away, and instead we'll allow any supported browser on any platform. So I could run Firefox or Safari on my Mac. I can run Chrome and Opera and IE and etc. on Windows. And what we're doing is, today hosted mode is an SWT application which wraps a native browser and is a binary, a 32-bit binary that runs for each platform. The new model will be a browser-specific plugin that can be installed. So for Firefox, I think it's a Zool plugin, and it will run on any version of Firefox on any platform. And that plugin, browser plugin, will allow the browser, the real native browser, to talk to the JVM while you're debugging. So it has a few advantages. One is that this 32-64-bit problem kind of goes away. And then the other is that the browser per platform restriction goes away. And then finally, you now get to test the full browser with all its plugins. So for example, hosted mode on Windows today is a version of IE, but without any real plugins. With this new model, you'll get all the plugins. So in Firefox, you'll get Firebug, for example. So again, the short answer is 64-bit, you'll be happy with the new plugin model, but we won't be porting the 32-bit SWT applications because it's frankly a lot of work for a limited benefit, and we'd much rather provide the new plugin mechanism, which is going to be very powerful. And in fact, if you build, I don't know, how many people have built a Google Web Toolkit application already? Anyone? And for those of you who have built one, how many have built off of Trunk, so do their own Google Web Toolkit builds? And how many are on Google Web Toolkit 1.6? Yeah? So what you can do is Google Web Toolkit has different production versions or deployments. So there's the 1.5, recently the 1.6 branch. And then there's also what we call trunk, which is the latest version out of the source control repository. You can download it. There's instructions on the website. And you build your own version of Google Web Toolkit, and you get all the latest functionality. So this plugin behavior is something that you can get. It used to be referred to as out-of-process hosted mode. Now we're kind of calling it in-browser hosted mode. I don't think we have a really good name for it. But this and a lot of other features are in source control, and you can try them out today. Thank you. Any more questions? And also, feel free after the session to come forward if you have a simple question, or find me afterwards in the conference. Thank you very much.